Hi there, friends. My name's Eli, and I'm one of the co-hosts of the TechSoup Connect Canada chapter. So today we're going to discover how nonprofits like Stand.earth use AI and machine learning to streamline research, save time, and money while driving innovation. This webinar is going to cover some technical issues like structuring your data, leveraging large language models, and crafting precision-focused metrics to uncover insightful insights from the mess of data we all are sometimes drowning in. We've got two guest experts who are going to present a case study of their work using AI to empower organizations to protect biodiversity and Indigenous rights. But I think this is going to be some general lessons that can be used across many different issue areas. Our smart people are here to blow your mind. Let me tell you about them. We've got Angeline Robertson, who is an award-winning researcher with Stand.earth in the research group. She is dedicated to environmental and social justice and utilizing investigative research to reveal issues related to the climate crisis, deforestation, unsustainable consumption, and human and Indigenous rights violations. Her investigations utilize a wide variety of data sources and methodologies, allowing her to create innovative analyses that drive impactful civil society campaigns. And she's joined by a colleague. We've got Matthew Lichty here, who is a data analyst also with the same organization. He has a diverse background in analyzing environmental, food systems, and public health data using fancy programming things like R, Python, and SQL or SQL, depending on how you sit in that fight. Prior to joining Stand.earth, he worked as a data analyst in academic, nonprofit, consulting, and government settings. And in his current role, he's responsible for analyzing data, computing statistics, writing code, and building new machine learning workflows. So with that, ladies and gentlemen, give it up to our guest experts. Go for it, Angeline and Matthew.
We thought about keeping the name that was advertised, but we also really wanted to just drive home the idea that we, as a research group, are interested in AI to save us time and money. Advocacy research doesn't have a lot of either of those things. And so, any ways that we can create those efficiencies and drive impact for the climate movement, we're really interested in exploring. So, really, this is about getting machine learning to do the grunt work in advocacy research and leave the human brains for the creative analysis and problem solving. Sounds great. We've all done a lot of grunt work in research. And to the idea that you might do a little bit less and actually be able to go further with the results is fairly tempting and interesting. So, our agenda quickly is very simple. We'll talk about the issue that we have been grappling with, our strategy for using AI. We'll go through the tool that we've created. We'll give you 10 top tips and we'll open it for Q&A. So, first, the issue. The issue at the heart of our work is the climate crisis. January 2025, for example, was the hottest January in recorded history, clocking in at 1.75 degrees on average, that's Celsius, above pre-industrial levels. So how do we get back under that Paris-aligned target of 1.5 to avoid the most catastrophic impacts of the climate crisis? One major piece of the puzzle is getting banks to stop financing fossil fuels. Our work in this regard is focused specifically on the efforts in Amazonia. This is an area spanning the Amazon biome, the hydrological basin of the Amazon River, and the adjacent areas influenced by the Amazon's rainfall. Amazonia represents the greatest concentration of biodiversity and the largest continuous forest on Earth. It is no place for fossil fuel extraction. So we really believe that it's time for banks to stop financing Amazon oil. Indigenous peoples have been warning humanity for decades that the Amazon rainforest is reaching an imminent tipping point, beyond which the Amazon will dry out and will burn more frequently, a trend we are already seeing. Fossil fuel extraction in the region contributes both to local forest and biodiversity losses, as well as the transboundary climate drivers of this tipping point. The rainforest's biodiversity and the rivers support over 40 million people across Amazonia, including over 5 million indigenous peoples, some still living in isolation from the modern world. And the Amazon's climate and the Amazon acts as a climate mitigation to cool down the planet. So we really believe it takes policy at all levels, including international coordination in the finance sector, to stop the current trend of destroying Amazonia for profit. To this end, we have been conducting research for over 5 years now on fossil fuel financing that goes to Amazonia. It started in 2020, looking at trade financing specifically from the Western Amazon for crude oil. And we found that there were 6 EU banks that had been financing the trade in Amazon oil over more than a decade to the tune of about $10 billion US. We were able to convince these banks to stop financing the trade, 4 of them making public commitments that actually were covered as a Reuters exclusive in 2020. And this was a huge kickoff for our research. In 2021, we then started focusing on bank policy and the gulf between banks' policies on paper and their financial decisions in practice. In 2022, we turned our sights to the supply chain for crude oil coming out of the Western Amazon specifically, and looked at the linked fates between the Amazon and oil production in the Amazon and its biggest global consumer, which is the state of California. And interestingly, the Amazon's tipping point and the droughts and dryness and fires that we've seen has a negative impact on rainfall in California. So it also can drive forest fires like the ones we've seen devastating California and Los Angeles specifically over this winter. And that really stresses the linked fate of all of us in the climate crisis. In 2023, we published our Amazon Banks database for the first time and highlighted the outsized role of just 8 top international banks financing fossil fuel production in the Amazon. They're responsible for over 50% of the financing that we observed. And in 2024, we really delved into the idea of the gulf between bank policy and their practice of financial decision-making and uncovered the greenwashing that exists in the financial system. As I said, the Amazon Banks database I referred to already is our online public database. It includes over 280 fossil fuel banks. It covers over 500 financial transactions over the last 2 decades, and it identifies over 23 billion US in Amazon oil financing that has gone specifically to oil and gas infrastructure and projects that have had adverse impacts on the ground. For this work, we won the Keeling Curve Prize in 2023, which was a huge early impetus for getting our work and thinking about how we can structure this work to keep it up to date and to keep putting pressure on banks to make commitments to ending their fossil fuel support. All of this research requires immense inputs of time and money for our team, both to explore and structure and clean data and to devise databases and analysis that supports the climate movement. We also have to keep this information up to date in order to keep up with the pace of development in research and knowledge about climate impacts. And this is all to put the latest and most impactful information in the hands of our Indigenous allies and others in the movement that need to be able to work on the forefront of these ideas and find the leverage points to facilitate positive change. So, how did we come up with a strategy for using AI? The first thing we did was look at what our top concerns would be with using AI assistance in our research. We highlighted data privacy concerns, content quality concerns, bias, energy usage, and associated costs. In terms of data privacy, we have an AI policy at Stand.earth so that we do not use any confidential, personal, or sensitive information. And that really is okay with us because we are really looking at publicly available information online for most of our data structuring work. In terms of content quality and content bias, Matthew will speak to that in more detail when he talks about the tool. In energy usage, we're really looking at which large language models commit to green energy. Right now, the best that we've seen is Claude by Anthropic, but we hope that this is something we've seen with DeepSeek, that potentially future AI tools would be able to be a lot less energy intensive. And I'll talk a little bit more about how we dealt with associated costs. But first, we really needed to think about what were the appropriate uses for AI in our research, considering all of these concerns. We wanted to do things with AI that we already knew how to do manually, but wanted to do quicker, more frequently, and more comprehensively than we had been able to in the past. So we selected data structuring tasks that free up our team's time. These things are like including unlocking unstructured data stuck in PDFs that you have to comb through manually, or you have to use keyword searches and also low thinking tasks that just take a lot of time, like data compilation and coming up with strategies for data categorization. We wanted something that could do what we've done manually, but do it 10 times or 1,000 times to produce more valuable data sets. We also needed a tool that could update our manually collected data sets. And we wanted a tool that would alert us to new information and would help us also to compare data sets so that we don't have to understand and read through and comb through things. We can actually just see if what we have is similar. And I'll give you an example. You may have two PDFs and just the quickest tool to decide if you need to read through them both or if they're similar enough or where their differences lie. So we weren't looking for AI tools that are going to remake the wheel for us or that are phenomenally different from the way that we normally work. We just were looking for how do we integrate AI into our methodologies in ways that allow us to go further in terms of our impact on the ground. And I'll give you an example. We're really going to talk today about our bank policy tool, not so that you understand it so completely, but as an example of what we were able to achieve. And I give you a little context for that so that when we're going through the tool, you can follow along. Banks create environmental and social risk management policies, and these are designed to prevent and mitigate adverse impacts to people and nature. They're also designed to mitigate adverse impacts to the bank, to their long-term business value, to their reputation. Sometimes the latter is more important to the bank than the former. But no matter what the quality of these policies are, this is really the source of bank due diligence when it comes to people and nature. So we analyzed 30 banks across 46 key terms that represent environmental and social values and risks. And we looked at things that fall into two main categories: exclusions or prohibitions, where the bank said that we will not provide any financing to this particular set of circumstances, and screens, where they say, we'll look very carefully before we make a financing decision. And across these key terms, we were really interested in environmental and social values that were spatially explicit or that can be mapped. And because these are such complex concepts to communicate to people, that if we could find ways to visualize them, we could start to convey things like greenwashing in a way that is very quick to understand. Essentially, what I'm saying is we'd go from this, which is the Citibank Environmental and Social Policy Framework, 40 or 50 pages. It's dense and complex, to this, which is a data frame of all of the separate environmental and social values and risks that we wanted to see if the Citibank covered and made commitments around, to this, which is a map of those commitments across Amazonia. And why this is important, we haven't quite got here yet with the tool, but this is something we're going to tackle in 2025, is that mapping this allows us to think about coverage. For example, a bank that talks about biodiversity protection and makes a commitment to not financing fossil fuel extraction in a UNESCO World Heritage Site may say that this is the way that they're combating biodiversity loss in the Amazon. But UNESCO World Heritage Sites only cover 2% of the Amazon, while we know that there are biodiversity values that are highly valuable across 100% of the Amazon. And so this is where we can explore and expose the difference between word and deed. And this really, so getting to our final point about our strategy and thinking about associated costs, we actually put an RFP out to a lot of data science firms, and we got quotes back that were already outside of our budget. Advocacy research is always done on a shoestring, and so we really couldn't afford to have this tool built by anybody else. that was disappointing. But when we started to think about it, we really actually didn't want a fully functioning, complete tool. We wanted to integrate AI into our methodologies. And so we decided that actually hiring a data science coach that coached our team in how to use AI was a far more effective and a less expensive way to build an AI tool and to also become accustomed to the methodologies in a way that we could scale and we could use these methodologies across our work. Our a data science coach was really great in helping us to customize and train a large language model that used our high quality manually collected data. And then we could use all the smart humans and all that domain expertise that we hold to check the model and to really vet the results. And finally, the strategy really included creating ad hoc and scaled approaches to address different research goals so that researchers could go and analyze a few things, or we could use a coded approach to pull a lot of data together and do a really big analysis depending on what the goals of our projects are. And with that strategy in mind, I'm going to pass it over to Matthew now to talk a little bit more about the tool itself.
All right. Thanks, Angeline. You can go ahead to the next slide. So this shows the overall workflow of our tool, and we're going to focus on steps 2 and 3 for now about how we got started by using the ChatGPT graphical user interface. This is a good place for anyone to consider getting started testing out whether LLMs can work for your situation. Next slide. Let's talk about the GUI approach. What is GUI? It means graphical user interface. And you're going to hear that acronym a lot in this world, so I'm just going to start saying it so that you get used to it. Next. The GUI for ChatGPT is how we got started building the tool before writing any code, and a good place for any other organizations to start similar projects. It allows you to develop and test prompts and also to run ad hoc analyses. When we started this project last year, we consulted our data science coach who told us that ChatGPT was by far the best large language model to use at that time. This was last year. But things change quickly in the world of large language models, and now you've probably all heard of other models such as Cloud from Anthropic, Gemini from Google, or DeepSeek's R1 model. These are all good choices, and I'm eager to try out these other LLMs as a next step in our project. We've also recently started using an interface called Perplexity, which I saw that someone brought up in the chat, and that lets you easily switch between other LLMs. So that's a great place if you want to get started with the graphical user interface and try a variety of LLMs. But for this presentation, I'm just going to stick with talking about our initial experience with ChatGPT, and pretty much all the lessons that I'm going to talk about here are transferable to other LLMs. Next. Within GPT's paid subscription, $20 per month, users can access custom GPTs for a variety of tasks such as research and analysis, writing aids, image generators, and so on. These have been trained to perform better at their specific use cases compared to the default ChatGPT interface. Next. There's also an option to create your own custom GPT by providing a set of instructions that guides its responses. You don't have to share this with anybody, or you could share it to users in your organization, or even make it available to any user on the GPT store. Most LLMs, like I mentioned, have a similar feature to this that works in a similar way. Next. Here's one of the first custom GPTs we made with instructions written off the cuff, but based on our extensive experience of doing this research task manually. One of the strengths of our DIY approach is that we already had years of domain knowledge, so we were able to start building these instructions based on our understanding of the policies. Next. Here you can see the results of when we uploaded Citibank's Environmental and Social Risk Framework PDF. It gave us this table, and this shows the first 5 rows. GPT's results looked amazing at first glance, but then when we looked closer and we realized it was missing some critical policies, and that what it labels as document text sometimes doesn't match the words written in the bank policy, but rather is a summary. Also, we noticed some of the classifications were off, and it became apparent that we could quickly get the LLM to output a seemingly impressive display, but getting usable data for our research was going to take more effort. Next. So how do you go from interesting results to a dependable research tool? How do you make a fancy new technology work for your practical data needs? What we did was leverage our data set that we had already collected to measure the model's performance and use that feedback to improve the instructions being provided to GPT, a process called prompt engineering. Next, I'll give you some of the most important lessons that we learned from our experience doing prompt engineering for this project. Prompt engineering is the process of crafting specific inputs, called prompts, to guide LLMs like ChatGPT to generate helpful and accurate outputs. Imagine a large language model as a tool that's like a search engine combined with a writer and a problem solver. But to get the right information or the right kind of response, you have to know how to ask the right questions in the right way. That's where prompt engineering comes in. It's about knowing how to phrase your questions or commands so that the model will understand what you want and provide the results that meet your needs. Prompt engineering is a skill that can be developed with practice, and a small investment of your time in getting better at it will pay dividends in terms of producing high quality responses from LLMs. Here's 3 best practices for improving your prompts. Be specific, break down complicated tasks into simpler steps, and provide instructive examples. Next slide. To be specific with requests, clarity and specificity are crucial because they directly impact the quality and relevance of your LLM's responses. This is a pretty basic example of this concept, just showing that it's worth explaining exactly what kind of information you want the LLM to give you. So you can see the bad request example is very simple. It says find environmental risks in the report. If you give it that, it's going to give you some information, but it might not be exactly what you want or the sort of information you're looking for. Whereas the good request example, which I'll just let you read instead of me reading out loud, gives more specificity. It lists out what you're looking for. It explains how you want it to be summarized. That's going to give you a lot better results from GPT or from any other LLM. Next, be specific with definitions. For example, in our bank policy prompt, we are very specific about what constitutes a key term match from our list of key terms. Otherwise, the LLM will make assumptions about what we do or do not want included. So we tell it that we do want to look for partial matches of keywords or for words that have the same meaning as our keywords, because those are going to be good enough. And it might only take it literally if we don't specify that we want it to look for these partial matches. Being specific about output choices can also be important for classification tasks where you may want it to select among a set of discrete answers, such as provide one of 3 responses X, Y, or Z. In this bit of our bank policy prompt here, we provide 3 options for the policy scope classification: project-related, all transactions, or corporate-related transactions and clients. Then we define each one so we can be sure that ChatGPT will choose one of these 3 options rather than making up its own classification. Next, be specific with outputs. The good example here sets a life limit of 200 words and asks for a specific kind of summary. As a different example specifying outputs, in order to get ChatGPT to work with our code, which I'll talk about later, we had to be very clear with it about returning information in a CSV format so that we could parse the data in Python, the programming language that we use. Next, it's important to break up complex tasks into smaller tasks. Often this is intuitive if you document how you would do this research without an LLM who would explain it to someone who may have no background on the subject. In our bank policy prompt, we ask the LLM for each of our 46 key terms to find relevant exclusion and screen policies. When it finds one, we ask it to then extract the chunk of text, label the text and the key term, and make 3 classifications for policy type, sector, and scope, which is what this slide shows in the abridged steps 1 through 6. Focusing the LLM's attention on specific tasks is critical for getting high-quality results, and how you divide the tasks can determine whether your tool functions well or not. Give the LLM too much to do, and you won't get high-quality results. I really encourage you to explore different ways of breaking down complex tasks, and I'll talk later about another way we do this. Next, providing examples can boost the LLM's performance. The LLM is hopefully already good at the straightforward cases you're asking it to handle, and you can use examples to guide it how to handle edge cases that involve more complex judgment calls. Here's a couple of the examples we use for our bank policy tool prompts. The first one on fracking is just showing that the LLM should be looking for variations of the term. in this case the full expression of fracking as hydraulic fracturing. The second example on oil spills is meant to signal to the LLM that it should determine that the main project risks of oil and gas pipelines are oil spills, and so it should mark this as a match if it's about an exclusion or screen policy. Next slide. Manually scoring the GPT results against our truth dataset was tedious. You don't need to read anything on this piece of paper because the point of it is that we just realized we needed to write some code to make this all happen automatically rather than doing it by hand. My colleague Brian would print out a sheet like this for each bank in our training set. Then he would manually score the LLM output against our truth training data to see how well that prompt version did for each particular bank. When there were wrong answers, he would look into the bank's policy documents to get a sense of why policies were missed or why it got a certain classification wrong. This was a great approach to get started refining our prompts in ChatGPT. It was improving our custom GPT's performance, but it was slow and labor intensive. So eventually, with the help of our data science coach, we wrote Python code to automatically do this process of checking results against truth data so that we could more quickly iterate through new prompt engineering ideas. Next, writing code allows us to scale up and speed up the process. Without getting into the actual code, I will talk you through a diagram that explains the process that we made. Next, the first step shows that we use Python code to access the API. And an API just means the way the code can interface directly with a program such as ChatGPT. In this situation, our code is technically interfacing with OpenAI because that's the parent company that houses ChatGPT. Similarly to uploading a PDF file into a custom GPT on the graphic user interface like I talked about earlier, the code uploads the whole folder of bank policy files into OpenAI into what's called a vector store. The vector store turns PDF files into a format that allows GPT to process them more effectively and store them in a smaller space. Next. While it's doing this, the code keeps track of the vector store file IDs to reference these policy files within the vector store. And then later it loops through each file ID and asks the GPT assistant to analyze the file. The assistants are analogous to custom GPTs in the GUI like I talked about earlier, and we can write instructions for them in the OpenAI backend website. Next. The assistants return output that the code converts into data frames, which are a form of structured data that the code uses basically like a spreadsheet, as you can see in the upper right corner. So there are essentially three inputs: the bank policy PDF files, the instructions for assistants, and our code that loops through each file ID and keeps track of the whole process. The output is structured data, which we can convert into CSV files or into Google spreadsheets for researchers to use as an aid in their analysis. Next. One big advantage of the coded approach is that for our training and testing phases, we can automatically calculate accuracy metrics for all banks we ask GPT to analyze, rather than having to manually score them ourselves like I showed in that picture earlier. So I'm going to show you how the code calculates aggregate metrics for just one bank as an example, but really it does this for all the banks in our training and testing data sets. GPT returns all the results from a training analysis, and the code extracts the policy summary tables into data frames. And then for each bank, it joins policies from the truth set, which is what we have verified as researchers, and from the GPT predicted set that we just received from its analysis. It joins the two sets of data based on policy names as shown in the table. So you can see that the rows highlighted in green have a policy name that matched in both the truth data and the GPT predicted data, which means they are true positives. The policies highlighted in orange are false positives because GPT incorrectly found a policy that was not in the truth data set. As you can see in the top row, adverse impacts of oil infrastructure. There's a blank under the truth column because there really was not a policy about that. And the policy highlighted in yellow is an example of a false negative because there was a policy in the truth data set that GPT missed. In this case, primary tropical forests has a blank in the prediction column because GPT failed to find it. From these measurements, we can calculate precision, which asks the question, how many predicted policies are true? The equation for this is true positives divided by true positives plus false positives. So in this case, it's really the false positives that count against the precision score. And we calculated recall, which asks how many of the true policies are predicted. The equation for this is true positives divided by true positives plus false negatives. So it really looks at the number of false negatives. We realized that recall was most important for our purposes because it's harder for us to spot false negatives when we use the results that help analyze bank policy compared to false positives, which are easier for a human to notice. In other words, we would rather have GPT include more results for us to look at rather than fewer. The code exports all these metrics into a CSV file, as well as the join tables, like what we see on the screen here, to show us how the metrics were calculated for each bank, so we can investigate oddities happening in the process. It also calculates a more generic accuracy score for policy type, sector, and scope. And as you can see here, the scope accuracy was lower than the others at 56%, and many other banks had a lower scope accuracy as well. So we implemented a prompt engineering solution called chain prompting that lets us focus a GPT assistant on scope alone to improve its accuracy. Next. Chain prompting is passing the response of one query into the instructions for the next. The first assistant analyzes policy keywords for each bank file. The assistant returns a structured data frame on policy name, type, sector, and text, but not scope yet. Then the code loops through that data frame and sends a message to a second GPT assistant with all the policy data we have now for each row, this time asking the assistant to determine only the scope for each individual policy. The second assistant returns a scope for each policy, and the Python code adds all the scopes as a column to the policy data frame that we already have for the bank. Having an assistant that only analyzes scope allows GPT to focus more and give us better results. Writing code to automate this process makes it possible to focus on one scope of one policy at a time, which would take too long if we were using the GUI for this case. Next. Here's some other ideas that we have in the works to optimize tool performance, which are in various stages of implementation. The ensemble approach is simply running the tool multiple times and keeping track of how many times it finds a policy amongst its runs. So if it finds a policy 1 time out of 5 runs, we can give that policy a lower confidence score and look at it with a bit of skepticism. But if it returns a policy 4 or 5 times out of 5, we can feel very confident about that policy. This can help us improve our recall as we're casting a larger net that makes us more likely to predict true policies. For smaller sets of keywords, we currently break up the list of keywords into 2 different groups to send to 2 different assistants, which helps GPT focus on less at once and improves our accuracy. We could break them up into more sets for more assistants, but we do run into a cost-benefit question, as it takes more time and costs more money to run more assistants. We did try splitting it into 4 sets of keywords, but we didn't find that it increased performance enough to justify the increased cost. Unlike the ensemble approach, which does cost more but improves recall enough that we think it's worth it. One of our next goals is to try different LLMs, and to try mixing them through the ensemble approach to further diversify the results we get, and to reduce the chance of getting bias from any one single LLM. For example, we could try 3 runs with ChatGPT, 3 with DeepSeek R1, and 3 with Cloud, and tally up the number of times each policy is found amongst them. The world of LLMs is constantly changing, so we need our code and methodologies to be flexible enough to adapt to the changes. For instance, Anthropic recently started integrating citations into Cloud's API, so it can reference page numbers of documents, and they claim this increases recall up to 15%. So my next step is to write some code that can utilize this feature while still working with a ChatGPT-based code that we already have. Next. Most of what I've discussed so far has been in the context of training and testing the LLM results against our truth data, so that we can figure out which prompt changes and techniques are actually improving our recall and precision. While we will continue to test new prompt improvements in different LLMs, we're also starting work on analyzing new policies from these banks, and eventually we'll analyze new banks and new sectors such as mining or agriculture. Next. This workflow in production starts with a web scraper that checks banks' websites for updated policy files and downloads any changed files into a folder. Then we run that folder of new files through the LLM tool with Python code and the assistants that we've already made, and we get structured data about bank policies. The structured data tables are uploaded to Google Sheets and shared with researchers, who can then use the results as an aid in their bank policy analysis. The LLM tool in production works with mostly the same code and same LLM prompts we've developed through training and testing. The only difference is that when we're analyzing new policies, we no longer have truth data to compare it to, so no recall or precision scores. But that's why a human researcher is still in the loop. double checking that the LLM result makes sense, but saving lots of time compared to starting from scratch with each new bank policy file. That's also why I like the ensemble approach, telling us how many times out of 10 runs the LLM found a policy, because it gives us a confidence score to work with. Next. The web scraper lets us know when the banks change their PDF files, so we don't have to check manually every time. We'll probably run it about once a month. A Google Sheet keeps track of the links to the policy PDF files, and the Python code uses something called XPath to identify the location of links to the PDFs. So you can see here, there's a little button that's an example from a website that says, read the public position on biodiversity. And underneath that is the underlying HTML code in which I've highlighted the link to the actual PDF file that we're downloading. Now, the PDF file is named biodiversity position 2021.pdf. That's obviously going to change from year to year, so we can't just use that PDF name or even that link because that's going to change. So that's why we use an XPath, which gets us to that point in the HTML code, so that then we can get the updated link even as it changes year to year. We can still download the link that we want. The code checks if the PDF has changed since the last time we ran the web scraper. Next. And for any files that do change, the web scraper notifies me, the data analyst, when it finds new policy files, and then it puts them all into a folder that I will run through the LLM tool. The results are analyzed by human researchers, who then add verified results into the database and let the campaign team know that they've added new data. These new findings may lead to new communications and engagements with the bank. Next. Just to recap what we said, our outputs are stored in Google Sheets, which we use as a simplified version of a database, where we can just simply add data from CSV files, and our data can be easily accessed by researchers and campaigners. Also, we store our code in GitHub for access for everyone on our team. And I believe it's back over to you, Angeline.
Thanks, Matthew. So we just wanted to wrap up with a couple of tips that we have felt are really important lessons that we've learned when we didn't come into this with a background in machine learning. And we really strive to integrate all of the lessons we got from our coach and also the adjustments we needed to make within the NGO to really make this worthwhile. So the first thing is to have an AI data policy to outline from the get-go exactly what kind of information can and cannot be used in an LLM, for example. I also really believe that starting with something but want to do faster is an excellent place to start to innovate with AI. We are 100% telling people to hire a data science coach and focus on training your team in order to really embed AI methodologies in all of your research instead of just coming up with a tool every time that has some complexities around and this also really helps with the integration of AI into domain knowledge, and that strengthens and allows researchers to create more time for innovation and for creativity, not just in the analysis, but we've been able to delve more deeply into data visualization and communication and think even strategically about building expert power and informational power. Starting with data structuring and use information available online. This has been, I think, the part that we have seen the best benefit is getting AI to do the grunt work, and using information available online typically we're not out there collecting data from the field. We're using and integrating and doing meta-analysis. So this has been an easy piece of this for us. Definitely, I think harnessing your domain knowledge is really key. The human in the loop with AI is a really important quality control. And also, AI is not going to be able to provide any insights that like your researchers can, but the insights that you're able to achieve when you're busy doing data cleaning for 60% of your time are much less. So harnessing your domain knowledge to build the AI tool is really about creating a more powerful process across the board. I think using more than one LLM is really important, and this is something that we've been exploring. We've mentioned already Perplexity, which I use for ad hoc research needs, so I can test the results across a variety of large language models. So for ad hoc and GUI approaches, this works really great. It's also really important for future proofing the tool so that as different LLMs go through version changes, you don't lose power in your research tool. And also to reduce the bias of any one LLM by testing across a variety of them. It does average out some of the bias you might see in one particular model over another. An important thing that we really learned early on was that good prompt engineering requires good writing. There's a lot of semantics involved in the kind of research that we're doing when you're looking at policy analysis, especially across lots of different languages, and you're looking at different ways of communicating policies and commitments across different regulatory environments. We really have to get really good at understanding and giving the LLM a lot of edge case scenarios and definitions, which is it's great at integrating, but really clear writing is so important to this process. LLMs have short attention spans. We've talked about that already, and it was a real revelation to break it down and to test how much and how simple should each piece be, or where could we still be a little more complex, whereas where we had to be very careful. And that certainly has helped us a lot. It was one of the biggest breakthroughs that we had. I think that GUI approaches are great for initial analysis and for ad hoc research needs, but that coded approaches are really important to analyze at scale and to create those cost efficiencies and time efficiencies that are going to be really important to your work. So it's a bigger upfront investment, but I think it pays off a lot. And also to keep that human in the loop, I think that sometimes there is an idea that gaining an efficiency is somehow removing a person, but really it's about empowering the people on our team to be able to do more with the work, to go further, to move faster, and to feel that they can achieve more with the work that they're doing and with the constraints that we have on our budgets and on our time. So yeah, those are some of our top tips. And now I think we will open it up to questions. But before that, I'd just like to say thank you for joining us today. I'm Angeline Robertson, Matthew Lichty, who presented today as well, and not on the call today, Wojtek Sedlak, who is our Digital Innovation Director. Just want to give him a shout out as well as the head of our research group.
Amazing. That was fabulous. Thank you so much. So much there. People are really wanting to follow up on this. So let everyone know that yes, the recording will be shared. And maybe the slides. We'll talk about that. And so there's a lot of amazing questions here. Let's start up with the thing that you really emphasized. And Larry Reed says, we get it. We need a coach. We don't want to just keep on hiring consultants. What was that process like? How did you identify that person? How did you identify what you really needed?
Yeah, we started out with writing an RFP and looking for a data science firm. And in those conversations and talking to people that we knew who gave us lots of sage advice, we really realized that we weren't going to be able to afford to do the kind of level of AI integration we wanted to have. And so that really forced us to innovate. And it was one of the conversations we had that pointed us to a firm called 16, who offered data science coaching, which was less of a cost. It's a minimum commitment per week. And you are paired up with a data science coach. Our coach is excellent, who he's also like a university lecturer. So he really came to the sessions ready and prepared. We gave all of our information a week in advance, and he was able to review code, partner code. He was able to review what the work we've done so far and structure some solutions for us and then present them. But all of the work, all of the actual effort, it was implemented by us as a team. And this has been a really fruitful relationship as well. In fact, we invited our data science coach to present on a series of workshops that we gave in November, which you can find online at Stand Research Group, stand.earth, /research group. I can put that in the chat if you need to. And so they have 16 and our data science coach Jack have also seen a lot of benefit in being in this environment and working with us and seeing firsthand what kinds of issues we're trying to solve. and where we want to put the emphasis in our work. And I think this is a really viable approach for people to take. Obviously, down the road, if you have a big front end data tool that you want to put out there for people, then perhaps a consultant or a data science firm it's a useful way to go. But we don't actually intend on creating any front end. This is all about methodology. For us, it's all about the things that we'll do internally. So that's not a big emphasis for us.
Nice. That's really helpful. So I've got a question here from Rachel who says, I love this list of like appropriate use cases for AI rather than the AI will replace us. How did you start identifying where you thought AI would bring the most value to the work you do day to day?
I can start here. Matthew can maybe pick up from this answer too. We were researchers and we spent a lot of time cleaning data. We do a lot of supply chain research, which is dirty data, and I thought that was the worst. But when I got started with financial research, I realized how bad it could get. And so we already knew that the time inputs, we were doubling our project timelines with the amount of time we had to take to structure and clean information. So I think that was already on our front of mind, was how could that help us with that particular problem. But what we learned very quickly was that we could, I guess I would say, like, data cleaning is a really boring task, but it forces you to go through the information. And sometimes in that process, you come up with some really interesting ideas. Our whole trade financing focus came out of me scoping a bunch of customs research and finding banks as the buyers of crude oil. And I was like, why are banks buying crude oil? Which was a thread that we pulled. And we realized that these were letters of credit. This is a type of financing. Oh, all of a sudden we have financial data somewhere we didn't expect to find it. So it's really important, but we also can't afford that amount of time every time. And what we learned with starting this process, obviously we had the issue coming in, we had the insight coming in, but we were concerned that giving the grunt work to an LLM meant that we wouldn't be as familiar with the data set anymore. But because of the chain prompting and the prompt engineering and all of the work that we had to do to structure the way we were asking our questions, we actually found ourselves really deep in the data set anyway, but in a way that was really creative. And it meant that the time we spent going in and thinking about the semantics and the writing of these prompts was actually helping us think about our analysis too. Matthew, do you want to add anything there? I think I might have gone off on a little tangent there. Sorry.
No, I don't think. I think you summed it up great. I don't have any more to add to that. Thanks.
So speaking of taking advantage of the areas where you have deep expertise and domain knowledge, Corey says, I've been in a situation where I've caught a ChatGPT trying to pass off incorrect or false information. And when I ask it for a source or explanation, it admits he just doesn't. I didn't have that data. Is there a way, Corey asks, can engineer prompts to dissuade it from attempting the task if it knows it's going to give false or incorrect responses?
Yeah, like I see that someone already responded in the chat to say to include in the prompt, be sure to include the URL where you got this data. I think that's one of the simplest solutions for any problem you have with an LLM is, well, tell it. If you don't like what it's doing, tell it to do something with more specificity. I think there's also a more complex technique that we talked with our data science coach about and have not yet implemented, called retrieval augmented generation, or the RAG approach. And that's a situation where you're basically feeding it like the exact data points, like the exact parts of a PDF file that are going to be relevant to it. So then it's looking through less data and it's more likely to use its source data in an informed way. And I mentioned we wanted to try the clouds or Anthropic's cloud because they have recently implemented a function in their API where they automatically give sources and cite the exact page number where they're getting this information. And I think they're even using retrieval augmented generation as part of that process. So I think using cloud is the way to get some of this improved recall and make sure that where you're getting your information from, or that the LLM.
Really about the show sources, just like I saw in your spreadsheet, you're like, you have this ranking, but you're like, and here's the specific actual text that it's referring to.
Mm-hmm.
Yeah. And another thing to go back to really utilizing your domain knowledge, starting with building a tool around something really so that you can identify where some of those hallucinations might be occurring. and going through and spending a bit more time with it. Like you saw Brian's, he printed out and wrote all over the sort of initial data frames we were getting back. And that's really useful to see where the hallucinations are more likely to occur. We saw the identified as policy scope was the most challenging part. It's also the one with the vaguest set of definitions and key terms. And it's also just a function of the data itself. Policy scope is full of terms that banks use that are interchangeable, whose definitions are overlapping and not discrete. So with that kind of messiness of the data going in, we also knew to anticipate that the LLM might try to augment the information coming back in order to make up for the fact that it wasn't so clear from the information we were feeding it what it should be able to do in terms of categories and classifications. So it's knowing your information going in as well and where it might actually be giving you some issues that might trigger the LLM to hallucinate some cleaner results than it's actually finding. If I can anthropomorphize an LLM there for a second.
Lovely. So time's moving quickly. So you talked a little bit about data structuring and how that was actually really key as well. What are some of like the things more broadly that you found work well when you're structuring your data so that the robot feels, oh yeah, I know what's going on here?
In terms of, I guess, the data that we're getting back from ChatGPT, we did
Or
struggle.
even just when you were structuring your own data to like start training it, like here's my examples of like truth, what it should look like.
I'll like handle that, Angeline, since you did most of that work, I think.
We built a database manually before we started, a smaller number, like as Matthew was saying, we had 30 banks already with what we call now a truth data set. And we'd had updated it once already. We have an internship program, so the interns were the lucky ones then. And so we were able to compare the two, if that's what you're asking, Eli.
Yeah, and I think part of my question is, so when you started taking that database that you already had
Yeah.
and started to use it within the LLMs, did you find that you had to modify your original database so
Yeah.
that it worked more effectively?
Yeah, we had some issues around classifications, especially in scope definitions.
Mhm.
Again, just because it's dirty, it's not a very discrete set of categorizations in the first place. We also found that we had missed things. So we were like finding things that LLM was finding that we didn't find, but we never fed the database in. We actually fed the PDFs that we had combed through manually into the database and got it to give us the same database again, but from the LLM. So then we could compare the two.
Ah, interesting. Right.
Yeah. So the testing set and the training set was like 20 of the banks. And then the testing set was the other 10 banks we did manually. We looked at and compared like what those look like from the LLM to what they looked like from the manual side. So the two were kind of two separate processes, and that allowed us to really understand both where we as humans had messed up and not found something, and where the LLM was coming up with recall and accuracy scores that we're either not hitting a threshold for us, or where certain parts of the prompts were working better than others.
That's really helpful. So you basically had, here's what I think it should be. Then I asked you to basically recreate that and then find the comparisons. Based on those comparisons, was it largely changing, like being more specific about like your definitions around there? Or were you just going in and doing a lot of changing the language of your prompts? Like what did you have to change to start bringing those two things into alignment?
Yeah, all of the above. I think Brian was the one doing most of that actual changing of the writing, and I think he went through 20 different versions or so of like fully reworking how the prompt works, changing how we define keywords, giving it different examples of different like edge cases, changing some of these techniques like I talked about where we'd have multiple assistants, one assistant that just focused on scope, or splitting the keywords into 2 or 4 different assistants and that sort of thing. So all kinds of changes.
We also quickly realized that we were going to spend a ton more time trying to get accuracy levels higher, when really we wanted the LLM to be really great at recall. And then we could use our domain knowledge to test the accuracy afterwards. And so we decided to double down on getting our recall really great so that it was capturing things that were our unknown unknowns.
Mm-hmm.
And then we were able to filter through that with our domain knowledge, and we were basically faster than the LLM at accuracy. And so we're also spelling, like we're making sure that we're using our strengths across our research group. So the LLM is doing what it's good at, and we're still doing what we're good at.
就这样 casual。
Thanks, everyone.